Greetings, Chem students. This is Mr. Braun, and today we're going to talk about the lab clear carbonated beverage solution and base titration. Basically, what you will be doing is you're going to find the concentration of a clear carbonated beverage. Now, what is a clear carbonated beverage? Two of them that come to mind are Sprite and 7-Up. They are both pops, they are carbonated, and they are clear. The materials you're going to need for this lab is a 24 well plate, 50 milliliters of distilled water. You can put that in one beaker, and you're going to have another beaker for a rinse water cup that you clean out your pipette with. You're going to need 6 toothpicks, and finally you're going to need 1 stretched pipette. Why are you going to need a stretched pipette? Well, if you look down here at the bottom, you are adding 70 drops of the carbonated beverage solution in one of the wells. That's a lot of drops. So that 24 well plate will overflow if you do not stretch the pipette. So make sure you have a stretched pipette. Now, it tells you to place different amounts of drops of carbonated beverage solution into wells A1 through A6. 20, 30, 40, 50, 60, and finally 70 on the bottom. After you have the clear carbonated beverage solution into those 6 wells, you're going to rinse your pipette out 5 times with distilled water. Once again, remember, this is just to clean your pipette. We need to use the same pipette to add the base as we did to the carbonated beverage solution. You're going to add 1 drop of phenolphthalein indicator into wells A1 through A6. Now remember, the phenolphthalein has its own little dropper. Okay, all you need to do is put 1 drop of phenolphthalein into that solution. Now I'm going to fill you in on a little hint. Your carbonated beverage solution is going to be an acid. So stop and think, what color is phenolphthalein when it's in the presence of an acid? That's right, ladies and gentlemen. It's going to be clear or maybe a little whitish, okay? Definitely not the pink color that we see when we have a base. If you would happen to see a pink color when you add that drop of phenolphthalein, you have a contaminated well. So you might want to redo that particular well. Now, we're going to use a base, and this, for this particular lab, the base is going to be 0.0500 normal sodium hydroxide. Okay? So what we will do, you'll fill the pipette with a 0.5 or 0.0500 normal sodium hydroxide solution, and you will add into well A1 drop by drop, stirring with the stirring stick, which is the toothpick. Okay, when you stir it and you have a pink color that lasts for more than 30 seconds, then you record the number of drops in the data table. We repeat this process for wells A2 through A6, and remember, use a new toothpick for each well. All right, so we repeat this procedure for A2 through A6. When you're finished, you can empty the contents of the well plate into the sink and clean the 24 well plate like we have been cleaning. Now let's get to our calculations. All right, right here we have calculations. We're going to have drops of bases in A1, A2, A3, A4, A5, A6. So we'll know how many drops of the base it took. All right, we need to use this calculation right there. Remember, the normality of the carbonated beverage solution times the volume of the carbonated beverage solution is equal to the normality of the base times the volume of the base. Okay? These numbers right here are all going to be volume of the base, A1 through A6 in your data table. Well, what's NB? What is the normality of the base? Well, we come back up here, right here. There is the normality of the base. What is the normality of the carbonated beverage solution? Well, that is our unknown. That is what we are trying to find. What is the volume of the carbonated beverage solution? Well, if I come right back up here, don't I have how many drops I've added? Absolutely. So we can do that calculation and we will get 6 different calculations of normality of the carbonated beverage solution. Now remember, the volume of the carbonated beverage solution changed in each well. Okay? Once we get finished, we need to find out what the average normality is for our carbonated beverage solution. So we're going to add up all 6 A1 through A6 normalities. We're going to divide it by 6, and that's going to give us the average normality of our carbonated beverage solution. Ladies and gentlemen, this is Mr. Braun. This has been the pre-lab video for clear carbonated beverage solution and base titration. Ladies and gentlemen, let's investigate.